Hello, geometry. How are you doing? Hopefully well. Today we are going to continue our introduction to looking at trigonomic functions, and we're going to continue with tangent, but today we're going to look at the inverse of tangent in order to find some angle measures. So you're probably going to want a calculator today, and I will show you how to use the calculator to apply inverse tangent. But let's just get started. So we're going to talk about inverse tangent, so I want to remind yourself what an inverse function does. So if you have some sort of function f here, all right, you have inputs of x and then an outputs a y value. So apparently, according to this function, if you input a -2, you get out a 15. If you input a -1, you get out a -7, all right, inputs and outputs. The inverse function, technically it undoes whatever this original function did. So if my original function, if I input a -2 and I got out a 15, well, the inverse function says, well, let me just input a 15 and I'm going to give you out a -2. So think about it as the inputs and the outputs of the original function have now switched places, right? So let's say that you have a value of 2 and you want to know what the input is. Well, if you input 2 into the inverse function, it'll tell you what your original input was in the original function, okay? So it's just, I just want you to make sure you know exactly what we're doing. It's kind of like undoing it. Basically, what we're going to do is we're going to switch some things around here, but it's going to look very much the same. So another just quick review from 3.1. Tangent of theta equals opposite over adjacent. All right, we talked a lot about that. I'm going to just write it out. Tangent of theta equals opposite over adjacent. And what does exactly that mean? Again, we have theta was like a reference angle, which was an acute angle in our right triangle. So just for example, I'm going to pick this acute angle to be theta. Again, I like using the Greek symbol here, but a lot of people just say, oh, it's just angle A, so they're interchangeable. Anyway, the tangent of theta was this ratio between the opposite side and the adjacent side in context to our reference angle here. So these opposite adjacent refer to side lengths. And in our right triangle, we always have our hypotenuse here. We have our opposite side, which is going to be opposite of our reference angle, theta. So that means that this side is our opposite side. And then the adjacent side, again, adjacent, like next to, right? So it's the side that's next to our angle theta that is not the hypotenuse, right? So here would be our adjacent side. Okay, so tangent of an angle is really just kind of referencing this ratio between the opposite side and the adjacent side. All right, so this function, if you think about it, it takes an input of theta and it takes an output of this ratio, right? So our inverse tangent should do the opposite. Our inverse tangent should take this ratio as an input and it should output an angle measure here. So we're going to write, so this is like our original function here, and this is going to be my inverse tangent function. I'm going to write tangent inverse, because if you remember up at the top, we usually write inverses with a -1 next to the original function. So this was the original function f, and then f inverse, so f like to the power of -1, if you want to think about it that way. It's a little misleading, but that's just how we write inverse functions. So tangent inverse of, now instead of theta, I'm going to take an input of my ratio opposite over adjacent. So opposite over adjacent equals an output of theta here. Okay, so that's what the tangent function does. It takes an input of a ratio and it will tell you, it will take this output of the angle measure. All right, this is what's in your book. I don't care if you prefer this one here or if you like this inverse tangent one from the book here. I'm just going to go through it one more time. It says tangent of angle A. So it's talking about angle A being this reference angle of theta. And we know tangent of an angle is opposite over adjacent. So here's my opposite side over my adjacent side. So that's why they have tangent of A equals A over B here. So in a right triangle with an acute angle A, tangent of A equals A over B, and the inverse tangent here, right? Inverse tangent, so tangent inverse of, now I have that ratio of opposite over adjacent equals the measure of angle A equals this theta, right? Okay, so that's that here. And on your calculator, if you want to get tangent inverse, it is right above the regular tangent. So you have to hit second to get to the option of tangent inverse. You have to hit second, and then you hit the tangent button, and then you can type in your ratio as a fraction, the opposite over adjacent. And if you hit enter after that, it will give you an angle measurement. All right, let's get some practice with our calculators real quick. Okay, this is the first example that I'm going to go over real quick, but I do want to show you how it's going to be like on a calculator. Because I highly doubt that you have the inverse tangent, all of those inputs and outputs memorized, right? So to use this, to use our calculator with this, I'm going to got a right triangle, and I'm asking, the question's going to be, find the missing angle. So I want to find this missing reference angle, theta, right? I know that's 90 degrees, but I don't know anything about these two angles in order to solve for the last one here. But I do know some information about my side lengths, and I do know some specific information about the side that is opposite of my reference angle and the side that is adjacent to my reference angle. So if I write a tangent function, I'm going to write the inverse tangent, so tangent inverse of my opposite over adjacent, right? Because my tangent inverse is going to take a ratio as an input, and it's going to output this angle measure. So in here, I'm going to write the ratio of opposite over adjacent. So I'm going to say 5 over 12. And that should give me my theta angle. Okay, so now I just have to figure out what's the inverse tangent of 5/12 on my calculator, and that's why I'm going to show you how to do this here. I have my original tangent function right here, and I see that tangent inverse right above it is in green, so I know I need to hit the second option. So I'm going to hit second, and then I'm going to hit my original tangent button to get me to this tangent inverse. I have tangent inverse there, and then I'm going to type in my ratio of 5/12. So 5 divided by 12, close parentheses, and then I'm going to hit enter, and I get 22.6. So the angle is about 22.6 degrees. On one of these calculators, I'm going to do the same thing. I have my tangent button here. I have my inverse tangent right above. I'm going to hit second. I'm going to hit the tangent. That gets me tangent inverse here. And then I'm going to type in 5/12. So 5 divided by 12. I like to close the parentheses at the end. And I do get 22.6 again. So here I have a whole bunch of examples. One of them I already did with you on the separate sheet of paper. But I do want you to either, if you feel comfortable, hit pause and try and find the missing angle here. So I have a missing angle theta, missing angle theta, missing angle theta right here. Hit pause, try these on your own, and then come back. 3, 2, 1. Hopefully you're ready to come back, or you didn't hit pause, whatever. All right, so I'm just going to go over this one real quick again. Tangent of, or I'm sorry, we're talking about inverse tangent because we're trying to find the missing angle, right? So I could set up an inverse tangent function. And again, my inverse tangent function takes an input of a ratio and it outputs my angle, what I'm trying to find. So I'm going to input into my tangent inverse ratio, or my tangent inverse function. Oh my goodness. My opposite side of 5 over my adjacent side of 12 equals theta. We plugged that into our calculator, and we saw that it was roughly 22.6 degrees. Again, we put our, from 3.1, your calculator should be in degrees mode, so you should be getting degrees as an answer. Okay, this one over here, I have a reference angle of theta, and I'm trying to find what theta is, so I know I'm going to use the inverse tangent. So I'm going to say tangent inverse of my ratio of opposite over adjacent has to be equal to theta. So my opposite side is going to be the 24, right? It's the side that is opposite of my angle theta, so 24 over the side that is adjacent. Okay, the side that's adjacent, that's not the hypotenuse, is going to be that 18, again, in reference to my reference angle theta here. So tangent inverse of 24 over 18, again, plug that into your calculator unless you have it memorized. So hit second, hit the tangent button, and you should get roughly 53.13. So it's about, I'm just going to round on the rest of these. It's about 53 degrees, okay? This next one over here, again, we're trying to find a missing angle, so I need to use the tangent inverse function. I need to input a ratio. So here I have, again, I'm going to kind of follow this reference angle. I'm going to find the side that is opposite, okay? So I have an opposite side length of 6. So I know 6 over, and then the side that is adjacent that is not the hypotenuse, right? Here, I see that this 10 is the hypotenuse because it is opposite of my right angle. And so I need to use the other side that is next to my reference angle of theta. So I need to use this 8. That would be my adjacent side. Okay, the adjacent side, the one that's next to it, that's not the hypotenuse. So I'm taking tangent inverse of 6/8. This ratio of 6/8 should be equal to my angle theta. All right, and then again, you plug that into your calculator, make sure it's on degree mode, and I'm going to just round it. It's 36.869, so it's about 37 degrees. Let me make that more of a degree sign. There you go. Alrighty, so hopefully those are some quick ones. Again, this is really just, can you write an equation for inverse tangent? And plug it into your calculator and you'll find a missing angle. All right, so this one here, last one, just a little word problem for you. It says find the measure of angle A between the turbine and the wire. So I'm going to zoom up here. Here's the turbine. Here's the wire. And basically what I'm asking for is, what is this angle right here? So I'm going to highlight that in yellow. What is that angle right there? So we're going to treat that as our reference angle theta. That's what I need to find. And I do have information about some sides that are opposite and adjacent, okay? Opposite and adjacent sides here. So I'm just going to write an inverse tangent equation. So tangent inverse of my sides opposite over adjacent, and in this case, the 10 feet is the side that is opposite of my reference angle. So 10 over, and then the side that is adjacent to my reference angle that is not the hypotenuse is this side length of 12. So I'm taking tangent inverse of 10 over 12 should be equal to my angle theta. Again, just plug that into your calculator, or if you want to make it even easier, it's not really necessary, but I could simplify that fraction on the inside, and that's what it does in your book. That's why I want to show you this. 10/12, that's really just 5/6. All right, that should give you theta as well. Again, plug either of those into your calculator, right? Because our our fractions were just simplified, but they're still the same thing. Tangent inverse of 5/6 is roughly 39.8, so I'm going to just call that 40 degrees, okay? So this angle right here, the angle between the turbine and the wire, is about 40 degrees. Okay, I'm going to write down tangent inverse. Takes our opposite over adjacent ratio, and it gives you your reference angle theta. All right, that's what we're doing. Fantastic. Have a great day, you guys. The homework is somewhere. I will let you know what the homework is. It's written in the Google Docs. I don't have it right now. Okay, bye. You're doing great. You're doing so great. Okay, bye.